What's going on, everybody? I'm always looking for new and better ways to make these spreadsheets useful to you as you're making your way through the course here, as well as your applications of statistics going forward. And so there's some additional things that I want to guide you through here that will increase the functionality of what it is that these things can do for you. So I'm going to have you take a look here at your hypothesis testing spreadsheet here. And there's some additional things that will make it so that you can use these spreadsheets all the more to be able to solve additional problems that we can throw at you in the course, as you're doing statistics here going forward. The first thing I want you to do is to go to the far left here, hypothesis tests involving the normal distribution. And in this same column here, where you had all of these labels, let's click in row 22. So we're in B22 here, and I'm going to have you put in the word percentiles. Okay, and then also move two columns to the right here, and I'm going to have you type in the words critical values. Okay, so we've got percentiles here that's in boldface, critical values here that's also in boldface. In fact, I think with these things, yeah, I'm wanting to make those both 11-point fonts since they're titles. Okay, and then here in the middle, in between these two here, there's a series of numbers that I'm going to have you put in here for this. So here they are, 0.001, 0.005, 0.01, 0.02, and hit enter after you type in each one of these so that we've got a new line for each one of them. So 0.001, 0.005, 0.01, 0.02, then 0.025, 0.05, 0.1, 0.15, 0.2, whoops, 0.2, 0.25, then we'll jump a little bit here. Let's do 0.5, then 0.75, then 0.8, 0.85, 0.9, 0.95. I'm going to have to scroll down a little bit here. And then after that, let's do 0.975, then 0.98, 0.99, 0.995, and then lastly 0.999. So notice that the numbers on the bottom here really mirror the numbers that are on the top. Not 0.999 plus 0.001 equals 1. 0.995 plus 0.005 also equals 1. So there's really sort of a symmetry between all of these numbers here. Now, what I want you to do is to select this whole region here. Let's put it in boldface, and let's also center it in between these, at the center of this column here, because we're really going to use these numbers here for a set of values that we put not only under percentiles, but also under critical values here. So here's the formula that we're going to use for percentiles. Let me hit enter here. Let me zoom in so that you can see the formula really easily here. Okay, so the formula here is going to be norm inverse. So norm INV, so the inverse normal distribution. And our first input value is this one right here, this value. So the 0.001 to the right here. And then we have two more values here. We want the mean and the standard deviation. And these should come from some parameters above. I think it's B10 and B11 here. So B10, that's our null hypothesis on the mean. And then B11 here will be this standard error of the mean. So yeah, it turns out that's right. That is B10 and B11 here. So let's type B, and I want you to put in a $sign, whoops, $sign before you type in 10. So B $10, and then B $11. End parentheses, that's all you need. Okay, and that should be the value that you can get there for this. Okay, let's make it so it's not boldface here. We don't need that to be boldface. But I would like you to take your cursor here and click on this lower right cell here and drag this down here so that we can repeat this same formula all the way down here, going from top to bottom. Okay, so you should have values that look like that. You'll probably have different numbers, depending upon what parameters you have up here at the top, but you should be able to fill that down here. And as you're doing that, you should be able to see that for each one of these cells here, the B10 and the B11 stay the same, but this value here should still be whatever number is to the right here. In this case, this is C27 because we're in row 27. Okay. Let's do the same thing here, but for critical values. So I'm going to go up and click on this cell here, and I'm going to put in a formula in here. This will be pretty similar to the one before. This will also be norm inverse, and it will take this value here as its first parameter. But this time, the mean will just be 0, and the standard deviation will just be 1. Okay, and in this time, your values definitely should match mine. Okay, and since this this formula is a lot simpler, we actually don't need to put any dollar signs in our formula anywhere, and we can just fill this down. Okay, and again, your numbers on yours should match what I've got here. If not, recheck your formula, make sure that these numbers are the same in the center here, as well as the formula here matches what I've got here. Okay, we're actually going to recreate this same thing here on the other side. So it might be of some value for us to just take this entire section here like this and select it upper left to lower right. So notice how I did that. I clicked on the upper left hand side here, and then I dragged my mouse down and let go at this point here. And so what I'd like to do now is edit, copy, and I'm going to zoom out here so that you can see where we want to paste this. I'm going to scroll to the right here, and now we're on this side here that involves the t distribution. And so I'm going to click directly under here at row 22. So this is M as in Martha, 22. And I'm going to go up to the edit menu and choose paste. Okay, the labels here are correct. The formulas are wrong. So all we have to do is just change the top formula here and then fill it down appropriately here. So let me zoom in once again so that we can do that. Okay, and here's the formula that we want to put in here. And it's significantly more complex than the one that we had before here, but still very doable. We're going to put in t.inv, so the inverse t distribution here. Our first parameter here is this value, so n23, n is in Nathan. Our next parameter here is going to be the degrees of freedom, which we get from going up top here. So let's go up. It's actually this, the sample size. So M is in Martha, 15, and we have to subtract 1 from that, so it's minus 1. So that is what we have so far. Let me actually hit enter there so that you can see what we have so far here. We have more to do, but I just wanted you to see what we have so far here. Let's also put a dollar sign between the M and the 15. And then scroll to the right here to the very end, and I'm going to multiply this by M as in Martha, $14, so M14, and then divide that by the square root of something. So square root SQRT. I hope you can see this. Let me make sure that you can see this here. Yes, good. So SQRT, and you're going to be taking the square root of M15, Martha 15. And then lastly, we're going to add M9 on this, Martha 9. And again, I'm going to put in some dollar signs here. So wherever you have an M, you should put a dollar sign before the number afterwards. So M15 here, this is going to be M dollar sign 15, and M9, this is going to be M dollar sign 9. Okay, so that's what you should have there. Okay, so at least now you shouldn't get an error with this. So I'm going to take this formula and I'm going to fill it down all the way to the bottom here, and there you go. So that one is ready. And then on the right hand side here, I'm going to do essentially the same thing as before. This will be a shorter formula this time here. But instead of norm inverse, this is going to be T dot inverse. N23 is the same, but we don't have 0 and 1 after that. What we want is to do degrees of freedom, which again is this value here at M15 minus 1. And again, here we're going to put some dollar sign in between M and 15. So we have two parameters on that. Let me scroll up here so that you can see that. Oh, it's not behaving very nicely. Let me hit enter and then go up here and show it again here. So that's what you should see for this right before we fill this down. And again, your numbers here for the critical values should match what I have on my screen here. So I'm going to click and drag this down here. Oh, they could be a little different here if you have a different value for sample size in here. So go ahead and put 35 in here for your sample size, and they should match. They should match exactly then. Okay, so that's what I wanted to add to this spreadsheet here. This will make it so that you can really enhance what it is that you're doing with our hypothesis tests that involve a single population here. There's actually a second spreadsheet I want you to create, and this will be for instances in which you're dealing with two populations. It'll be similar to what we had before here. So there'll be a lot of duplication that we've done before here. So let's actually let's actually do this here. What I'd like for us to do is to create a second spreadsheet here. Whoops. And we're going to call this hypothesis testing 2. All right. And here's what I want you to put in the upper left here. This is going to be 2 population hypothesis tests. And this, ironically, we're going to have the one for the t-distribution on the left, and then we'll have another one for proportions that'll be on the right, which actually uses the z-distribution. So things will switch on this one here, but I think it'll be okay. So we're going to scroll to the right. Let me actually scroll to the right here. And under column P as in Peter, we're going to do the same thing. Type 2 population hypothesis test, and in parentheses put PROP for proportions. Okay, so those are our 2 titles there. Again, I'm going to make it so that they're boldface and 18-point font. And let's go to the left-hand side here. Column B, row 3. Let's put in our display parameters. Okay, so display parameters title, this will be minimum, this will be maximum, and then DX right here. So these things, these first 2 here will be input values, and then we'll leave the third one as a calculated value. The next cell here is B8, so we're going to say given. We'll say given population difference. And this is our only input value underneath here. So that's there. To the right, I'm going to put null hypothesis on mu1 minus mu2. However you want to spell that is fine. And then lastly, standard error of the difference. All right, let's skip a row then, and let's go down here, given, and in parentheses, sample. And below this, we're going to put sample 1, and to the right of that, we're going to put sample 2. Okay, and then in this column to the right of all of that, we have sample mean, sample standard deviation, and sample size. All right. All 6 of these cells are input values. So we're going to color those green. And then underneath that, we're going to have this for output. And to the right of that, we're going to put t-score, the probability that little t is less than big T, and the probability that little t is greater than big T. Okay, so I have a lot of things to boldface here. Let me do that. Boldface, 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 whoops, boldface, 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 and these 3 will be boldface. This is boldface, and these 3 are boldface here. And in addition to that, let me make it so that these titles here are in 11-point font here. This is 11, this is 11, and just this one up here, given sample, that's 11, and then output is 11. Okay. In addition to that, I want you to go into your previous hypothesis testing spreadsheet that we just created here, and there's this whole section right in here with the percentiles and the critical values that I want you to select. Upper left to lower right. We're going to go up and edit, copy, and then we're going to find our new spreadsheet here, and we're going to paste those starting in row 23, column B. So there we are there. So again, the labels are correct. The formulas are all messed up there, but we'll figure out those in just a moment. Okay. On the right-hand side here, we're going to do something similar. Okay. So we're going to start in row 3 here, just underneath 2 population parameters. Excuse me. Hi, sweetie. How are you? Good. I am. Okay. Yeah, actually, I'm recording a video right now, so can I call you back in about 10-20 minutes? Okay, just go to my Gmail and take care of that thing. Okay, cool. All right. Thanks, sweetie. All right. Bye. Sorry about that. Uh, so let's put in underneath in cell P3 here, we're going to put in display parameters. And this will be the same thing here, minimum and maximum and dx. Let's keep going down here. This will be given population difference. And below that, to the right, we're going to say null hypothesis on P1 minus P2. We'll also put standard error of the difference. Okay, and let's move to cell P12, and let's type given, and in parentheses sample, and below that let's type sample 1 and also sample 2. And to the right, let's say sample proportion, sample standard deviation, and then sample size. And then also underneath that, let's put P bar. So that'll be one thing there that we're adding to this. Then underneath that, let's put in cell P19 the word output. This will be to the right. This will be a z-score, probability that little z is less than big Z, and probability that little z is greater than big Z. And then, you guessed it, below that, we're going to be putting in this large set of numbers here that I want you to copy from this point and paste it in the appropriate place at this point here, probably starting at cell P24. So I'm going to go up here and say edit paste. And so at least we have those labels in correctly here. Let's boldface this, boldface these, boldface this, boldface these, boldface all of this, and all of this, boldface this, and all of this. Let's also make these titles 11-point font here, 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 and and here. Okay, and then also recognizing what things here are actually input values and what things are not. The first two up here are input values. For the second one here, it's only the null hypothesis that's actually an input value. The other one is calculated. And down here, there's actually only two rows that are actually input values. There's this first row, and then below that, the third row, not the second row, but the third row is also an input value. The one below that is an output value. And nothing down here is an input value. So, all right, we've got those things figured out. And so we've got the essentials of what we're going to be doing here with these. Let's go to the left-hand side here and start to fill in some of these formulas here. Let's just put in some example input values in for minimum and maximum. The formula for this, as always, is equal to B5 minus B4. That whole thing is in parentheses, divided by 1,000. And that's our value for dx. For an example value here under population difference, let's say 0. And let's hold off for a moment on calculating this underneath it. Let's give some example values here for the sample. Let's say the sample mean here is 319 with a standard deviation of 153. and a sample size of 800. And for the other one, it's 521 with a sample standard deviation of 171 and 847 samples. All right, so these are two different normal distributions, essentially, well, t-distributions, that have different means. One has a slightly larger standard deviation to it, but it also has more samples to it, so that might squish it in a little bit more there. So we're trying to see if these two uh, means are distinct, if these two populations are distinct from one another. And so we actually have to calculate the standard error of the difference between these two populations based upon not only the mean and standard deviation, but also the sample size here. This is going to be, this formula here is going to be equal the square root of B15, so this sample standard deviation here, and it's got to be squared. So the caret, shift 6, the caret for an exponent here, and we'll type the number 2, and we'll divide that by the sample size, B16. Okay, then plus, do the same thing with these two cells here. This should be, this is C15, that should also be squared, and we'll divide that by C16, with C15 and C16 there. Okay, so end parentheses, I'm going to zoom in on that so that you can see what that formula is here. There it is. Okay. All right, let's scroll down, see what else we can fill in here. These output values here, calculated very, very much the same way as before here. Here's our formula, equals, and in parentheses, B14 minus C14 minus B9 all over B10. There we are there. So that's our C-score here. It's actually calculating the difference in the sample means and dividing that by the standard error of this difference. So seeing how far away that is. Good grief. We have a t-score here that is astronomically small here, so we should really get a probability here that's near 0 when we put in this formula here. So this will be equals t dot dist. Our first parameter here is the t-score. And then we're going to say, for the second parameter, it's going to be the minimum of two things here. Minimum of these two sample sizes. Okay, so minimum of B16 and C16 here. You can either have a colon in between them or a comma. Either way will work. But end parentheses on that, we have to subtract 1 from that as well. And then lastly, our third parameter here is true. Okay, so the degrees of freedom, we have to take the smaller of the two values here. That's what this is all about. So in this case, it's going to choose 800 over 847, the minimum value of these two locations here, and then subtract 1 from that to get the degrees of freedom. Okay, so as we predicted, that's pretty much 0 here for a very extreme t-score. This one is just simply equal to 1 minus this other p-score. These two things always add up to 1, so you can calculate one from the other very easily. And so that's obviously going to be just equal to 1 here. Okay, so let's come down here, and we've got some formulas to put in here for percentiles and critical values. Let me come in here, and this is not going to be norm inverse normal. This is going to be inverse t here. So let's change this to t dot inverse, so the inverse t distribution here. Our first parameter, as always, is this one here. This is the probability that we're putting in. And then just like before for our degrees of freedom, we have to choose the minimum of these two values up here that I can select. So those two right there in parentheses. I always have to subtract 1 from that. And we want to multiply this by B10, this right here, and then also add, whoops, that's not what I was looking for there. So we want to come to the end of this formula, multiply this by B10, and then also add B9. Okay, and wherever we have a B, basically anything inside this minimum value here or after, we want to put in some dollar signs here. So $B, $16, $C, $16. Let's scroll to the right a little bit more. This should be $B, $10, and then $B, $9. The C24 shouldn't have any dollar signs on it. Okay, so that's our first percentile formula here. And now we can just do this fill down thing, where we just fill it down to the bottom here, and that's all filled in very nicely. Okay, the critical values here can be very similar. So equals T dot inverse. And again, our first parameter here is this number, C24. And again, we're going to have to, for degrees of freedom, define the minimum of these two sample sizes up here. And I'll subtract 1 to that here. And then I'll just end the formula with this right parentheses here. So once again, we have to put in some dollar signs in front of B and 16 as well as C and 16. And that's all done there. Okay, and I'm going to fill this down here so that we've got everything there. Okay, so we've got this part here done. Let's scroll to the right and do the same thing here with this part here for doing hypothesis tests on two proportions. For minimum and maximum, we're pretty much always going to want to set this to 0 and 1 unless we're really zooming into something, because proportions don't really go below 0 and they don't really go above 1. And so we'll just work with that. That means that this value here is going to be very simple. It's going to be equal to, in parentheses, this minus this. It's just going to be 1. We'll divide this again by 1,000, so that should be 1,000th. Very good, yeah, 0.001. Let's scroll down here, and for this, let's just put a 0 in for the null hypothesis on the differences in those two proportions here. Before we do this formula down here, let's scroll down to the sample information here. And so for this sample proportion, let's just say 7% for one, and let's say 8% for the other. For a sample size here, let's say 2,000, and for a sample size here, let's put 2,200. All right, so let's start filling in some of the formulas here with this. For the sample standard deviation here, so I'm clicking on P15. I'm going to put in a formula here for this that allows for us to calculate the sample standard deviation here. If you recall, the standard deviation here is just equal to the square root of P times Q all over N. And so we should be able to calculate this based upon these two numbers here very easily here. So I'm going to start with equals, and that's going to be a great big square root of a bunch of stuff here. But my first number is this one, P14 times, in parentheses, 1 minus P14, 1 minus P14, end parentheses, Okay, so we've multiplied those two things together. And then we're going to divide that by P16. That's the sample size there, P16. And then we'll end parentheses on that square root. And we get something that looks like that. Okay, so a very, very small standard deviation here, mostly because our sample size is so high. All right, let's do the same thing over here. And I'm thinking we might be able to just click and drag the formula here for this. And yes, we can. So if you click on this one, you can just drag it to the right here, and this formula will copy into this area here. There was no need for any dollar signs on any of these formulas here. Everything's just copy over very nicely. All right, let's calculate P bar down here. This is something that's peculiar to when you're working with two different populations with two different proportions. You have to try and estimate sort of a universal proportion that kind of allows for both of them to handshake together here. So here's the formula for this. This is going to be equals it's going to be equals in parentheses P14 times P16 plus Q14 times Q16 in parentheses divided by parentheses P16 plus Q16 end parentheses. So there it is. That's that formula there. Now, don't confuse the pluses from the stars here. Make sure you get those correctly here. It's P14 times P16 plus Q14 times Q16. And that's all over P16 plus Q16 here. All right, so that should give us a proportion that's somewhere in between 0.07 and 0.08. That's basically saying that, yeah, out of every one that we've sampled, the combined proportion here, the average proportion, the weighted average, really, in the proportion is about 7.5%, which makes sense here. 7%, 8%, 7.5%. So we have to create kind of a temporary weighted average of those two things in order to be able to calculate the standard error of the difference up here, which we will do now. So let's go here, type square root, and this is going to be P17, that's our P bar, times in parentheses 1 minus P17 times in parentheses 1 divided by P16 plus 1 divided by Q16. End parentheses, end parentheses. Hopefully you can take a look at some of these things and perhaps compare these formulas with the formulas that we're discussing in class. You know, some of these things you can take a look at what we're doing here and you can say, oh, that's that formula that Withrow's giving us in class here. So yes, this is the formula for the difference here, and it involves P bar times 1 minus P bar, and this is 1 over N1 plus 1 over N2. That's all of that in parentheses as well. So perhaps you can locate that formula and see that I'm really just imitating all of that here. Okay, so there we go, the standard error of the difference between these two things. All right, here's our z-score. It's equal to the difference between P14 and Q14. And we'll also want to subtract off the null hypothesis way up here, this here, P9. Okay, so all of that in parentheses divided by P10, the standard error of the difference. And that's going to give us a z-score here. It's marginally significant, probably not something that'll be totally statistically significant here, but let's see what what we can get here from this. So for this formula here, equals norm dist, and our first parameter here is this z-score here, and then the last three parameters are 0, 1, and true. Yeah, not very significant. So p-value of 0.11, not very significant here. And then this bottom one here is just going to be 1 minus the top one, equals 1 minus the top one right here. Okay, so yeah, that should be 89% since this is 11%. Good. All right, so let's scroll down here and let's get these percentiles put correctly here. Here we're working with proportions, so we're back to using the normal distribution, as is evidenced by the fact we're working with z-scores here. So we're going to be working here with norm inverse here, but let's make sure that our numbers are correct here. This should be P9 and P10. That's not too far off, is it? Q25 for the first parameter, that's right, row 25, column Q, so that's correct. So it was really just those two parameters that needed to be set correctly, wasn't it? Okay. All right, so good. Let's fill that down. Oops. Okay, all the way down there. So those are all filled in. And then for the critical values here, this should be norm inverse of Q2501, and those are actually, that formula is actually correct here, norm inverse Q2501. So all of these formulas here should be correct, and they are. Okay, very good. The only thing we have to do is create those charts, with all those numbers once again here, so that should be pretty quick and straightforward here. Let me, first of all, create those columns here to do this. Let's go over to column L, actually column K here first. And so let's go to cell K4. And let's put in a 0 in here into column K4. And let's do 1 and 2 below that. And let's select all three of these cells and then fill this down until we get to 1,000. All the way down there to 1,000. Let's just add just about 5 more rows there at the bottom. So we want this to go all the way to 1,000. Oh, okay, so I've got to select 2 of them here so to get the right idea. Yes, I have to add 1 each time. All right, so we've gotten to 1,000 here. Very good. Hopefully you can all see that if I move it over here. So I was able to fill that down all the way over here. And then let me scroll up. And for this next column here, I'm going to put X on top here, and then distribution 1 and distribution 2 here. This value here for X is going to be equal to B4 plus B6 times, I think it's K4. I think that was my, yes, K4 here. So B4 plus B6 times K4. And these values here for B4 and B6 should have dollar signs in front of them there. B4, B6, and K4. Okay, so that's good. So this is starting at 20, which is what our minimum was here. And as I fill this down, it should go all the way to 30, which is what the maximum was for this. Yep, it ends at 30. Okay, so very, very good. Let's fill in things here for distribution 1. And this is probably going to be our most involved formula here. So it's equal to T dot dist, 2 left parentheses, L4, that's this value here, the 20, minus B14, I believe That is, yeah, the sample mean there. So minus B14, right parentheses, divided by left parentheses B15, divided by the square root of B16. That's the first parameter there. Oh, we have to, one more in parentheses there. That's the first parameter there. So L4 minus B14 divided by B15 over square root of B16 here. So this is the difference divided by the standard error here. Second parameter, B16 minus 1. And lastly, the word false. We're not doing the cumulative distribution here this time. Okay, so, and wherever we've got B's instead of L's, we should have dollar signs in front here. So dollar sign $B, dollar sign 14, dollar sign $B, dollar sign 15, dollar sign $B, dollar sign 16, dollar sign $B, dollar sign 16. Okay, so we've got that one here. Let's actually do the other one here as well, and we'll fill both of them down at the same time. So equals tdist. Once again, two left parentheses, and then L4, that's that number to the left there, the x value again, minus C14. Let me scroll to the right here just so, oh, you had to be difficult. All right, let me just end it there so I can open it up again. See in a way that you can all see it here. All right, L4 minus C14, right parentheses, divided by left parentheses C15, divided by the square root of C16, end parentheses, comma, C16 minus 1, comma, false, end parentheses. So there we are. And once again, we should have dollar signs in wherever you see a C. C14. There should be dollar sign C, dollar sign 14, dollar sign C, dollar sign 15, dollar sign C, dollar sign 16, dollar sign C, dollar sign 16. Okay, so we've got those two here. Let's click and select those. Let's fill those down. Okay, so there we are there. Okay, so and let's also select this whole three columns here so that we have a nice little border grid around all of them here. There we go. And let's make these things nice and boldface on top here. Okay, let's also make it so that we can't see these numbers going off down the side here. So I'm going to select all of them. I probably could just select the column here when I do this, but whatever. And I'm going to make it so the numbers are still there, but I'm going to make it so the text color is just white. So now you can't see them. But the numbers are still there. You can actually see them up in the upper left-hand corner here. That's still 999, but you just can't see it because it's written in white. Okay. Let's actually do the same thing over here for the second set of hypothesis tests here. And so let's start in cell Y4 here. You know what? Let's actually just copy column K here. Copy over to column Y. Okay, so once again, these should be invisible, written in white, but I can click on this one here and see the number 3 in the upper left up here. So we did copy this over here. We should be able to add some more columns here. Let me insert columns to the right, and again columns to the right, and again columns to the right, and again columns to the right. Okay, so let's click in cell Z3, and this will be our value of X. This will be, the one to the right will be distribution 1, and then distribution 2. Again, we can make those in boldface, like that. And our formula here will be very similar to the one before here. This will be equals P4 plus Y4 times P6. And again, wherever we have a P instead of a Y, we should put a dollar sign in front of both parts. Dollar sign P, dollar sign 4, plus Y4 times dollar sign P, dollar sign 6. Okay, so that's going to give us a 0 there. And then let's actually do the other two here as well so that we can just fill them in. So here's the formula underneath distribution 1. This is going to be norm.dist, norm.dist. And our first parameter is going to be this right here, Z4, and then P14, and then P15 divided by the square root of P16. Okay, and then lastly, the word false. And again, wherever we've got a P instead of a Z, we put dollar signs in front of both parts. Dollar sign P, dollar sign 14, dollar sign P, dollar sign 15, dollar sign P, dollar sign 16. Okay. And lastly, this column right here, this is also going to be a norm dist. Again, it's going to be Z4 to the left here. This one's now going to be Q14, then Q15 divided by the square root of Q16. And then lastly, false. And wherever there's a Q, let's put in dollar signs. Dollar sign Q, dollar sign 14, dollar sign Q, dollar sign 15, dollar sign Q, dollar sign 16. Okay, let's take all three of these and let's fill this down. Okay, I think it's going to go all the way down there. Okay, very good. Let's also put some nice borders around this. Okay, so that's going to be all set there. All right, it's going to be a very tight set of distributions here. Okay. Very nice. Let's make some charts, and then we're done. Okay, so let me zoom out here to 50%. So we're zooming way out now. So I'm going to put my first chart for this data right here. I'll put the second chart for this data right here. So let's do this. I'm going to select just distribution 1, distribution 2, all the way down here. Okay. And then let's scroll up to the top. And we'll say insert chart. Okay. And it's confused as to what to do here. Not a column chart. We want a line chart here. And the data range is going to be this. Let's add an x-axis here. This should be this data range here. This will be L4 through L1004. Okay. And so that is pretty good here. Let's also customize this with a chart title here. We'll just call this distributions 1 and 2. That's about all the labeling that we really need to do here for this. So that's essentially everything there for this one here. The fact that it's not showing much has to do with the fact that these sample means are way outside the display parameters here. So if I made this 1,000, then yeah, that's showing a lot more here. Okay, let's do the same thing here for the distribution to the right. These are going to be even tighter. Okay, so let's scroll up to the top and say insert chart. And again, we want this to be a line chart here. We've got two things for the y-axis here. And what's our column here for the x values? It's column Z. Okay, so add x-axis. This here, this is going to be Z4 all the way over to Z1004. Whoops, 1004. Okay, so that should fill those things in. Come on, fill those things in appropriately there. And let's put in a chart title here for this. Again, this is going to be distributions 1 and 2. Okay, so we've got that listed here. So again, this is going to be showing the distribution of sample means given the null hypothesis, actually based upon what you're getting from your samples here as well. So um, this is going to be really, really useful for you. So I think this is going to do it here. I'd explain more, but I think we've done so much here that I think it's important that we stop at this point here. So at any rate, this has been probably one of the longest videos that we've done here. Sorry about that, but I think it's going to be it's going to produce some important benefits for you in class. See you in class.